This is our work on robust active visual perching with quadrotors on inclined surfaces by Jeffrey Mao, Chris Kroninger, Steve Nogar, and Giuseppe Luiano. Our goal in this project is to create a system that allows quadrotors to perch autonomously on any planar surface up to 90 degrees. Currently, our work involves multiple target localizations and plannings. We call this procedure Active Visual Perching, or AVP for short.
We also implement a linearized FOV constraint based on a conical model of the camera's FOV to ensure the drone has line of sight to the target. This FOV constraint is sparsely enforced over the entire trajectory, and we use the KKT conditions to tell when this FOV constraint is feasible with a perching constraint. In these following slides, we will show the difference between the AVP method and the one-shot. Here at 4.5 meters, only the AVP method is able to successfully intercept the target, unlike one-shot, which falls short. Our current AVP method also maintains a longer target detection than the previous one-shot with no field of view constraint. Moving forward, we also include a close-up video of our perching maneuver. Our method is also generalizable to lateral motions as demonstrated in the following. Finally, we develop a simulation to verify our perching maneuver and the associated FOV constraint in a variety of conditions.